Yes, hello guys. Today I will talk about what are the inverse functions and differential coefficient of inverse functions. So differentiation of inverse functions. Differentiation of inverse functions. Inverse functions. Okay, so what are the inverse functions? What are the inverse functions? Let me define first. What are the inverse functions? And we know that for every bijection, means 1, 1, 1, 2 function, let me take that that bijection function is f from x to y. Okay, there exists another bijection g such that y to x. Okay, for every which is defined as g y equal to x, or if and only if g x, sorry, if and only if f x equal to y. Okay, so let me define this. What is inverse function? Okay. In bijection, we know from bijection. What is bijection? Bijection of function 1, 1 on 2. 1, 1 on 2. Okay, from bijection, that for every bijection, bijection function, let me take that function f such that x to y, this is get to y, there exists another bijection. There exists another bijection. There exists another bijection g such that y tends to x. Y tends to x, defined as gy equal to x, if and only if this is IFF, that means if and only if fx equal to y, for every y belongs to y, equal to y, let me write here, for every small y belongs to capital Y. Okay, and this is equal to x for all x belong to capital X. Okay, in this way. And how do we express it? And this, let fx equal to y, our inverse function is expressed. So this implies that f inverse y equal to x. Okay, so for f inverse is defined as this way. So let me take some functions. Okay, f of f inverse or f inverse of f is known as f inverse of x. F inverse of x can be defined as f inverse fx, which is nothing but f inverse, and fx is y. This is f inverse y, which is equal to x for all x belongs to x. Okay, this is how it's also defined. F inverse of a function f, which is defined on x. F inverse fx is y. You know that f inverse y equal to x for every x belongs to x. And this is also defined that f inverse of y. Right, so this is equal to f inverse y, which is nothing but f of x is equal to y for all y belong to y. This is how inverse functions are defined. Now let me take what is differentiation of differential coefficient of inverse trigonometric functions which are in the course. Okay, how do we differentiate trigonometric functions which are inverse trigonometric functions? So let me talk about inverse trigonometric functions. So inverse of trigonometric functions and how they are differentiated and what are their coefficients. The differential coefficient of trigonometric function, that is differential coefficient or derivative of inverse trigonometric functions. Inverse trigonometric functions. That is inverse trigonometric functions. Let me take one by one. There are 6 inverse trigonometric functions. Can be 6 here. So let me take first that y equal to sine inverse x. How do we differentiate them? And what is differentiation of sine inverse x? So by the definition of inverse function, here sine y equal to x. Okay. Now differentiating this, let me take this first equation. Differentiating first with respect to x on both sides. So differentiating, right completely. Differentiating first on both sides with respect to x, we get, if I differentiate this with respect to x, so let me write x with this side, ddx of x equal to ddx of sine y, which can be written, this is y. Okay, variable is y here, but we are differentiating with respect to x, cannot be differentiated, so by function of a function rule, dd by of sine y, we can written as dy dx. Now this is gdx, dy dy can be out. So nothing, but this is equal to sine y. What is differentiation? No. Now we can differentiate sine y because variable is same. We are differentiating with the same with respect to the same variable. So it can be differentiated now. So this is cos y d by dx. Alright, and here it is 1. So 1 equal to cos y d by dx or ddx of y. This implies that ddx of y is equal to 1 upon cos y. Okay, now cos y is to be expressed in terms of sine y. So this is nothing but 1 upon under root 1 minus sine square y, which is 1 upon from the first equation under root 1 minus x square. This is the differentiation of y here, this y, and y is inverse sine inverse x. Sorry, this is ddx of y, ddx of sine inverse x, which is nothing but under root 1 upon 1 minus x square, under root 1 upon under root 1 minus x square. Right, so this is the differentiation. Now this differentiation is to be remembered by the students, very, very important one. The answer, the result of this, the differentiation of sine inverse x must be known to the students, so that should be remembered by the students so that questions can come out. Let me take the next one. What is differentiation of another trigonometric inverse function or inverse trigonometric function, which is, take the second one, let y equal to cos inverse x. Okay, this implies that cos y is equal to x. First equation. Now let me again differentiate it with respect to x on both sides. Differentiating first with respect to x on both sides. On both sides, we get. On both sides, we get x. Let me take x to left hand side. So ddx of x equal to again ddx of cos y. I'm differentiating both sides with respect to x, but this is y variable. So from function of function, this is to be differentiated with respect to y. Right, cos y. Okay, dd by cos y, but it was ddx, so ddx is there, is still there. From this we have to obtain the differential of cos y is minus sine y dy together. Now here it is 1 d dx of x with respect to x, we are differentiating. Differentiation of x is 1 with respect to x. So 1 is equal to this is minus sin y dy dx. Now this implies that dy dx, which we have to calculate, dy dx or d dx of y is equal to minus 1 upon sin y. Now as we are having here cos y equal to x, so this sin y is to be expressed in terms of cos y, which is equal to minus 1 upon under root 1 minus cos square y. We know that from trigonometry, sin square theta plus cos square theta is equal to 1. Let me write here, since sin square theta plus cos square theta equal to 1, and from this sin square theta is equal to 1 minus cos square theta. 1 minus cos square sin theta is equal to, therefore, square root of 1 minus cos square theta. So in that way we have written. Now this is equal to 1 upon minus 1 upon under root 1 minus x square. Differentiation of cos inverse y, here cos inverse x, is nothing but this is y here, therefore d dx of cos inverse x, or y is here y is cos inverse x. Y equal to cos inverse x. Here y equal to cos inverse x. We are substituted at place of y cos inverse x, so d dx of cos inverse x is minus 1 under the root 1 minus x square. Now this from trigonometric relationship we can also calculate what is differentiation of cos inverse y or cos inverse x with the help of sin inverse x. Let me differentiate. We know that from trigonometry or indirectly we can obtain differential coefficient of I'm writing brief coefficient of cos inverse x with the help of trigonometric relationship. What is that trigonometric relationship? This sine trigonometric relationship with sin inverse x. And we know that sin inverse x is what? So let me write here. We know that cos inverse x equal to pi by 2 minus sin inverse x from trigonometry is given. Therefore, differentiation of cos inverse x is equal to differentiation of this whole. What is that? Therefore, d dx of cos inverse x can also be obtained in this way, equal to d dx of pi by 2, which is constant 0, minus d dx of sin inverse x. Alright, so this is equal to 0 minus sin inverse x. Differentiation of sin inverse x, we know this is 1 upon under root 1 minus x square. So by this method also we can calculate differentiation of cos inverse x or differentiation of sin inverse x if we know what is differentiation of cos inverse x. Then sin inverse x can also be obtained because sin inverse x plus cos inverse x equal to pi by 2, and cos therefore sin inverse x equal to 1 minus pi by 2 minus cos inverse x. So in that way differentiation of both can be obtained with this relationship. Okay, this cos inverse x equal to pi by 2 minus sin inverse x, or sin inverse x plus cos inverse x equal to pi by 2. With the help of this equation we can obtain the inverse of each other. Okay, so differentiation of inverse of each function. Now next let me take the third one, which is tan inverse x. The third differentiation which is left y equal to tan inverse x. What is differentiation of tan inverse x and the trigonometric inverse function? So let me find out dy dx. So here x equal to, this implies that x equal to let y equal to tan inverse x, so x equal to tan y. Differentiating first. Taking the first equation, so differentiating first with respect to x on both sides. With respect to x on both sides. On both sides, we get differentiating first with respect to x on both sides. We get ddx of x is 1, we know this. Okay, that's our right heading. Again ddx of 10y, sorry, it's 10y, ddx of 10y, but this is y, so we have to, by the with the help of function of the function dy of 10y, it can be differentiated now. dy, ddx of y is to be multiplied, okay, by chain rule. We know this from function of this function. I'll explain this in the previous lecture. Now come to the point. This is equal to how much? Here it is 1, and that is 10 by is second square by into dy dx. This implies that dy dx or ddx of y is equal to 1 upon second square by. Now second square by in terms of 10 by, because here we are having 10 by equal to x. So we have to express in terms of 10 by. So this is nothing but 1 upon 1 plus 10 square by x square theta equal to 1 plus tan square theta. We know this from trigonometry. This is nothing but 1 upon 1 plus x square. So differentiation of tan inverse y, therefore ddx of tan inverse x, substitute value of y here, y is tan inverse x, ddx of tan by tan inverse x is equal to 1 upon 1 plus x square. This is, okay, differentiation of tan inverse x. Now let me take cot inverse x. So what is differentiation of cot inverse x? Let me define that also. Now differentiation of cot inverse x with the force of that y equal to cot inverse x. This implies that x equal to cot y. Sorry, cot y, of course, but this is cot y. Okay, first equation. Now differentiating first with respect to x on both sides. Differentiating first on both with respect to x, that is right here, with respect to x on both sides. On both sides we get this is ddx of x, that means 1, in the similar fashion ddx of x cot y, which is to be expressed in chain rule, dy of cot y into dy dx or ddx of y. So this is nothing but what is differentiation of cot y minus cos x square y. This we know from trigonometry. Minus cos square by cos x square y ddx of y. This is 1. So 1 is equal to minus cos x square y into ddx of y. This implies that ddx of y is equal to minus 1 upon cos x square y. And from trigonometry, cos x square y is to be expressed in terms of cot y. This is nothing but minus 1 upon 1 plus cot square y. You know that 1 plus cot square theta equal to cos square theta. Okay, so now substitute value of cot y. Cot y is x. This is minus 1 upon 1 plus x square. Okay, so cot inverse x, essentially, this is, let me write here. Okay, so by ddx of cot inverse x is equal to minus 1 upon 1 plus x square. Now this can also be obtained from a trigonometric relationship between tan inverse x and cot inverse x. So what is that relationship? Let me find out the same result. Differentiation of cot inverse x with the help of one relationship. Which is that relationship? We know this from trigonometry. This is this corollary of that question. We can also find out. We can also find out ddx of or differentiation of cot inverse x with the help of this formula. With the help of the formula, we know that cot inverse x equal to pi by 2. Pi by 2 minus tan inverse x. Right. cot inverse x equal to pi by 2 minus tan inverse x. Now differentiating both sides, we get ddx of cot inverse x, which we have to calculate, suppose, equal to ddx of this whole, ddx of pi by 2 minus ddx of tan inverse x. Now ddx of tan inverse x, we know this is 0, this is minus 1 upon 1 plus x square. ddx of tan inverse x, we know that is 1 upon 1 plus x square. This is with minus sign, minus 1 upon x square. With this relationship, you know that tan inverse x plus cot inverse x to pi by 2 trigonometry. This is also can be used directly. Value of this can be of. Okay, so this is another relationship. Now let me take the fifth trigonometric relation on trigonometric inverse function. Inverse trigonometric function. That fifth one is, let me take y equal to secant inverse x. Now secant inverse x, for the differentiation of secant inverse x, let me shorten. This implies that x equal to secant y. Let me take first equation. Again differentiating first with respect to x, x on both sides. We get on both sides we get x, ddx of x is 1, because we are differentiating x with respect to x, so 1. Now ddx of secant y. Okay, so this can written as dd y of secant y, because variable is handled by function of function, by the help of function of function, ddx of y. Okay, so this is 1. ddx of x is 1. 1 is equal to ddx of secant y is secant y into tan y. Differentiation of secant y is secant x into tan. So secant y into tan y, in this case is dy dx. This implies that dy dx we have to find out. ddx of y is equal to 1 upon secant y into tan y. Right? Now express tan y, because secant y is already there, secant y is x, secant y can be replaced with x, but tan y is to be expressed in terms of secant y. So that is equal to, okay, or this is ddx of y, ddx of y is there, secant x, or secant inverse x. Secant inverse x y is equal to, so in place of y we have to give this. This is equal to 1 upon secant y is x, from this x under root, because tan y can be expressed in terms of secant y. That means secant square theta minus 1 tan theta, or this is secant square y minus 1. Now substitute value of secant y, this is x under root x square minus 1. Okay, value of tan y in terms of secant y. That means sec square theta is equal to 1 tan square theta, and tan square theta is equal to sec square theta minus 1, and tan theta is equal to under root sec square theta minus 1. Sec square theta minus 1, sec theta is, sec y is here in this case 1, so yes. Now differentiation of sec inverse x is 1 upon x under root x square minus 1. Okay, now the sixth one, and the differential coefficient, inverse function, trigonometric inverse function, that is the sixth one. Let y equal to cosec inverse x. If y equal to cosec inverse x, this implies that by the definition of the inverse function. Okay, so x equal to cosec y. This is first equation that we take. Now differentiating first with respect to x on both sides, so we get differentiating first with respect to x on both sides. On both sides we get fixed. So ddx of x again. So ddx of x is equal to ddx of cosec y. Sorry, cosecant y. This can be differentiated with respect to y, because variable is y. This is cosecant y into t by ddx of y. Okay. Now ddx of x is 1, so 1 is equal to cosecant y ddx of cosecant y minus cosec y into cos y. This we know about. What is differentiation of cosecant y, cosecant theta, that is equal to minus cosec theta into cos theta. Cosec y minus cosec y into cos y into d by dx. D by dx. Okay, this implies that we have to find out ddx of y, which is from this one minus 1 upon cosec y into cos y. Okay, so this can be expressed as, now cosec y is x, so x, now again cot y is to be expressed in terms of cosec y. We know that means cosec square theta minus 1 equal to cot square theta. So this is cosec square, let me write here, cosec square y minus 1 under root, this is value of cot y equal to cosec square theta minus 1. That means this is 1 upon minus 1 upon x under root x square minus 1. Okay. Now this is the sixth trigonometric inverse trigonometric function. Now this can also be obtained by the relationship of, let me solve it in another way. We know that what is differentiation of secant inverse x. Okay. So from the relationship we know that secant inverse x plus cosec inverse x equal to pi by 2. This is pi by 2. So therefore cosec inverse x we have to calculate equal to pi by 2 minus secant inverse x. Right? Therefore ddx of cosec inverse x is equal to ddx of therefore ddx of pi by 2 minus ddx of secant inverse x. Now ddx of pi by 2 is 0. 0 minus ddx of secant inverse x, which is nothing but 1 upon x and the root. We have just calculated. With the help of this relation, this is minus, this will be minus 1 upon x and root x square minus 1. This is differentiation of cosec inverse x with the help of secant inverse x. This relationship is to be remembered. There are three relationships: sec inverse x plus cosec inverse x to pi by 2, sin inverse x plus cosec, sin inverse x plus cos inverse x to pi by 2, tan inverse x plus cot inverse x to pi by 2. So with these relationships, we can calculate these functions. Now how? Okay, there is another relationship. Let me define. There is a function of inverse function. How do we solve inverse function? We know this, that d by dx or ddx of y into dd of x equal to 1 for cancel of 1. Or this implies that this relationship is very useful in case of finding out differentiation of inverse functions. Therefore ddx of y is equal to 1 upon left dx dy. Alright, dx dy. Now if I take, and here both the derivatives dy dx and dx dy are known as 0. They cannot be 0, otherwise they are not defined. Okay, or both cannot be. Here both derivatives are not zeros, are not equal to 0. Not equal to 0. Okay, are not equal to 0. That means only then they can define. So for every when dx tends to 0, dy also tends to 0. Okay, so for every delta x, let me take delta x. Delta x tends to 0, delta y also tends to 0. If I write del y delta x, limit delta x tends to 0. Right, this is equal to 1 upon limit delta y tends to 0. This is delta x limit delta y. If I write this formula, this one, in this way, in the limiting form, in this case delta x tends to 0, delta x tends to 0, delta y delta x can be expressed in terms of limits. Okay. 1 upon limit delta y tends to 0, numerator 1. So it can be expressed in this way. So this is how we apply this formula. So therefore, d by dx equal to 1 upon dx dt y of x. Okay. This is how we can calculate this function. Now, let me write some inverse functions. If there is f inverse y equal to x, this we know. Okay, f inverse y, f inverse x equal to, or this implies that fx equal to y. Okay, if I differentiate this, or if fy equal to x, let me take fy equal to x. If I differentiate this with respect to y, so ddx of, dd by of x equal to f dash by, because I'm differentiating this equation with respect to y. This is nothing but f dash by. Right. This implies that ddx of y is equal to 1 upon f dash by. Why? Because this is dx dy equal to f dash by. So f dash by can be written. This is nothing but 1 upon what is fy, y equal to f dash of f inverse x, then f inverse x. Y is f inverse x. Y equal to f inverse x. If I write fy equal to fx equal to y, and f inverse y equal to x equal to f inverse x equal to f inverse y, f inverse x equal to y of f inverse y. Okay, so in this way, these equations are very much helpful in case of calculating inverse functions. Okay, this form. Okay, so now let me take some examples which are how do we use these trigonometric functions, inverse of trigonometric function, in case of differentiation. Okay. How these differential coefficients are helpful in case of solving questions. Let me take some questions. Right. First, let me write some questions and solve them. Okay. So, first question, let me take. Solve the following, or differentiate the following. Solve the following, or differentiate the following. Differentiate the following. Find the differential coefficient of the following functions. Y equal to, let me take tan inverse x upon a. How we have to differentiate when there is the angle is different from, so not the angle, the value of this tan inverse function is different from a, x, which is x